First, let's meet our celestial visitors. NASA has been tracking these two asteroids, officially designated 2024 AH4 and 2024 AV2. The names might not be catchy, but their size is what's grabbing headlines. Both are described as being roughly the size of a house. To put that into perspective, imagine an entire building, a pretty large one at that, hurtling through the vacuum of space. It's a powerful image, and it's happening right now. So how close are they coming? This is the million-dollar question, isn't it? NASA's Center for Near-Earth Object Studies, or CNEOS, is the team responsible for keeping an eye on these things. According to their calculations, these asteroids will make what's called a close approach to Earth. Now, in astronomical terms, close can be a very relative word. It doesn't mean they're going to skim our atmosphere or crash into your backyard. Let's look at the numbers. Asteroid 2024 AH4 is projected to pass us at a distance of about 2.2 million miles. That's roughly 9 times the distance between the Earth and the Moon, so while it's considered a near-Earth object, it's still comfortably far away. You won't be able to see it with the naked eye, but it's a significant event for astronomers who use these flybys to study these ancient space rocks up close. The second asteroid, 2024 AV2, will come a bit nearer, but still at a very safe distance. Its trajectory brings it to within about 1.8 million miles of Earth. Again, that's several times the Earth-Moon distance. So the key takeaway here is that there is absolutely no risk of impact from either of these asteroids. NASA is very clear about this. Their warning isn't a call to panic. It's part of their routine planetary defense mission. So why the warning, then? Why all the fuss? Well, tracking these objects is a critical part of what NASA does. By studying the path, speed, and composition of asteroids that come relatively close to us, scientists can refine their models and improve their ability to predict the orbits of other, potentially more hazardous objects in the future. Think of it as a fire drill for the solar system. We practice and gather data on the small, non-threatening events, so we're fully prepared if a truly dangerous one ever shows up on our cosmic doorstep. Every day, Earth is bombarded by tons of space material, but most of it is tiny like grains of sand and burns up harmlessly in our atmosphere, creating the beautiful shooting stars we sometimes see. Larger objects, like these house-sized asteroids, are much rarer. And it's objects of this size and larger that NASA's Planetary Defense Coordination Office is tasked with finding, tracking, and characterizing. The technology behind this is incredible. Telescopes on the ground and in space, like the Pan-STARRS system in Hawaii and the Catalina Sky Survey in Arizona, scan the skies every single night. They're looking for faint points of light moving against the background of stars. When they find a potential candidate, a network of observatories around the world springs into action to confirm the discovery and calculate its orbit with high precision. Let's talk a little more about the asteroids themselves. What are they made of? Most asteroids are remnants from the formation of our solar system, over 4.6 billion years ago. They're like cosmic time capsules. They come in different types. Some are rocky, made of silicates and clays, while others are metallic, rich in iron and nickel. And some are carbonaceous, containing organic compounds, the building blocks of life. Studying the composition of asteroids like 2024 AH4 and 2024 AV2 gives us invaluable clues about the early solar system. By analyzing the light reflected off their surfaces, a technique called spectroscopy, scientists can determine what they're made of without ever having to land on them. Each flyby is a precious opportunity to gather more of this data. Now, what if an asteroid of this size was on a collision course with Earth? A house-sized asteroid would be a significant event. It likely wouldn't be a global catastrophe, but it could cause major regional devastation, similar to the Tunguska event in 1908. That's when an object, estimated to be of a similar size, exploded in the atmosphere over a remote part of Siberia, flattening trees over an area of 800 square miles. This is precisely why NASA's planetary defense work is so important. It's not just about tracking. It's also about developing ways to deflect a potential threat. You might have heard about the DART mission, the Double Asteroid Redirection Test. In 2022, NASA successfully slammed a spacecraft into a small asteroid moonlet called Dimorphos to change its orbit. The DART mission was a test of what's called a kinetic impactor, basically hitting the asteroid with a projectile. But scientists are also exploring other methods. One idea is a gravity tractor, where you'd fly a massive spacecraft alongside the asteroid for a long period. The spacecraft's tiny gravitational pull, over years or decades, would slowly tug the asteroid onto a different, safer trajectory. Another concept involves using lasers or focused sunlight to vaporize part of the asteroid's surface, creating a jet of gas that acts like a small rocket engine, pushing the asteroid off course. The key to any of these deflection techniques is time. The earlier we spot a potential threat, the less of a nudge we need to give it to miss Earth entirely. A tiny change in velocity years in advance can translate to a miss of thousands or even millions of miles by the time it reaches our neighborhood. That's why the constant, vigilant sky scanning is the most crucial part of planetary defense. So as 2024 AH4 and 2024 AV2 sail harmlessly by, we can see it as a successful test of this system. They were detected. Their orbits were calculated. They were determined to be non-threats. And now they're providing valuable scientific data on their way past. It's the system working exactly as it should. It also highlights the dynamic and ever-changing nature of our solar system. We tend to think of the planets orbiting the sun in a neat, orderly fashion, but it's a busy place. There are millions of asteroids out there, most of them in the main asteroid belt between Mars and Jupiter. But the gravitational pull of giant planets like Jupiter can kick them out of the belt and send them on paths that cross the orbits of inner planets, including Earth. These two house-sized asteroids are just two of the more than 30,000 near-Earth asteroids that have been discovered so far, and astronomers are finding new ones every single day. The goal of the Global Tracking Program is to find 90% of the objects larger than 140 meters, which are the ones that could cause truly widespread devastation. We're getting closer to that goal, but there's still work to be done.